because although what Maddie said you could do, it works nicely now, but if that 93 had been a much larger number, it might take you 49 minutes to get up and find out how many terms there are. And you won't have 49 minutes for one problem when it comes to test time. So you're going to want to know how to get there without just pushing the button on your calculator or whatever you're doing. So, yes. Okay, you find the explicit formula first because this sequence should be something that you know. So what is the explicit formula? That's it, right? You all know how to do that. Now you want to find out what term number 93 is. Is it the 14th term? Is it the 83rd term? Which term is it? Well, to do that, what do you do with 93? Yeah, it's your a sub n value. It's the value of the nth term, so it takes the place of a sub n. Now, couldn't you solve that? Add a 7. Divide by 4. And therefore, n is 26. So that's how you get n to be 26 without just punching it into your calculator over and over. Now that you know n is 26, what we're going to be finding is the sum of the first 26 terms. So it's s sub 26. And that's going to equal, you now know n, don't you? 26 over 2 times, you know a sub 1. It was given, you know a sub 26. 93, it was given. Now this is just a pretty simple problem, right? 13 times, or what, 86? And is that 1,118? Okay? It is. All right. So does that make sense with this? Okay, here's what I'm going to do today. I'm going to start with the lesson, which is going to be going over some of the things that you read and making sure that you really understood what you read. Then we'll talk a little bit about your homework if I need to clarify anything. But part of your assignment for today will hopefully be to finish anything you didn't get done if there were questions that you had. If I need to get you started, I will, but then you can finish up those things. Then I have a few more problems to add. And then I'm also going to, hopefully by now or after today, the extra credit will make a little bit more sense. And I think, let's see, today's Tuesday. I think I'll say Friday. The extra credit will be due by Friday. If you didn't write it down, you can write it down again today because I'll be putting it back up again today.
Oh, okay. So you know how the way that I did the first problem, but there's like an easier way that you showed us? Mm-hmm. What if we did the extra credit we did?
Okay, well now you know this way.
But I already did it.
I will look at it, but I may, I mean, if you're pressing it on your calculator, then that it said that you had to show all work to get credit. And so if it's just calculated, if it's just calculated.
I wrote it down. I'm not even kidding. Look.
Oh my. Gee whiz. Okay. What you were reading about was something called summation notation. I think there was 1 page worth of reading, and it was on summation notation. And summation notation is how you notate a sum, if you will. And you probably saw this symbol in your reading quite a bit, and it said things like this. And in here, there was some kind of a function. I'm just going to say f of n for right now. Okay? The way that this is read is it's the sum from n equals a to n equals b of f of n. Okay? And the way that you figure these out is you start out by putting in whatever number is in the lower, well, I guess I should clarify that. This thing right here we call the lower bound. It's the lower bound of your sum. This one up here, any ideas? The upper bound. It's the upper bound of your sum. And they should always be integer values. Okay? And the way that this works is you start out by taking whatever integer this one is right here, and you plug it into your function, and you figure out its answer. Okay, so you put in a, and you get f of a. Then you go up one integer. So you'll now be plugging in a plus 1. And you put a plus 1 into the function, and you figure out whatever a plus 1 is. Then you go up one more integer. So now you'll be at a plus 2, and you plug that into the function. And what you're going to do is you're going to continue this process until your integers finally reach whatever number this happens to be. So the second to last one will be f of b minus 1, and the last one will be f of b. You're going to evaluate all of these. You won't be writing down f of anything. You'll just plug it in and get the answer and write the answer down. Then, guess what you do with all these answers? You add them together. That's what this notation over here means. It says take all of these answers and add them together. Okay? So let me show you an example that has a real function in there and real bounds. So if we had the sum from n equals 4 to n equals 9 of, let's just say, let's do n squared plus 1. The first thing you do is you take your lower bound of 4 and you plug it in. If you put 4 into that expression, what do you get out? 17. So write down a 17. Now you go up to the next integer. Well, after 4 comes 5. You plug in 5. What do you get out? 26. Go to the next integer. It will be 6. Plug 6 in here, and what do you get out? 37. Now plug in 7, and you get 50. Then plug in 8, and you get, and finally you plug in, and you get, and how do I know to stop there? Because 9 is my upper bound. Okay? Now, guess what I do with all of these numbers? Add them together. And as soon as you add them together, you've got your sum. Okay? Okay, does everybody see where I got those numbers? 17, 26, 37, 50, 65, 82. Everybody's good with that? Okay? And some of you probably already have it summed up by now. That's fine. I'm pretty confident that you can do that at this point. Now, this thing right here is always going to be, or what we're going to do right now anyway, an explicit formula of some kind of a sequence that we've already looked at. So series and sequences are very much related. If you have a series and you can figure out its related sequence, which is easy, right? All you have to do is take away addition and subtraction signs and replace them with commas, and don't you have the sequence? Okay? So if you know what that sequence is, if I give you either an arithmetic or a geometric sequence, can't you always write an explicit formula for that? Okay? So if you can get the formula, you're going to be able to take a series and write it in summation notation form. Let me show you. So it says use summation notation to write the series 8 plus 16 plus 24 plus ... for 50 terms. Okay? So we make our summation sign. We're going to start with n is equal to. Now, this lower bound, you pretty much can start wherever you want. Although, if you're going to go for 50 terms, probably the easiest lower bound would be to pick 1. Because 1 will stand for the first term. 2 will stand for the second, 3 for the third, 4 for the fourth, so on and so forth. If I want 50 terms, then what will the upper bound have to be? 50. So if you start at 1, then it's pretty easy to get that upper bound. Okay? Now, in here, to get the little formula that goes in here, it's just the explicit formula of the related sequence for this series. Well, you know the related sequence, don't you? It would just be 8, 16, 24. Isn't that the related sequence for the series? Just take out addition signs, put in commas, you've got the sequence. Can you write the explicit formula? Yeah, it starts out with 8, the first term. What's next? Plus 8 n minus 1. Right? Now look at that. 8 plus 8 times the quantity n minus 1. Can't that be simplified? And it's going to simplify just into plain old 8n, isn't it? And you distribute the 8, combine like terms. So I am going to write it like that. N is equal to 1 to 50 of 8n. Now, what I would like to do is I would like to find this sum. We already know it's an arithmetic sequence, don't we? Or I'm sorry, an arithmetic series, because it's a sequence that we're adding up all the terms of. And don't we have a formula for finding the sum of a bunch of terms in an arithmetic series? Yeah, it says to do, what was the formula? You just gave it to me a minute ago. N over 2 times a sub 1 plus a sub n. Okay, what's n in this case? How many terms are we summing? 50, you were told. So it's going to be 50 over 2 times, do we know the first term? 8. Now, we don't know the 50th term because it's not listed up there, but can't we figure it out? Yeah, we've got the explicit formula. It's 8n. So the 50th term would be 400. 8 times 50. Just put in the upper bound. So this turns into 25 times 58. Oh, thanks. Sorry. Yeah, that should be a 400. Thank you very much. How about 25 times 408? That sounds better. Which is 10,200. There we go. 50 times 8. I accidentally wrote down 50 instead of 50 times 8. Do you see how that works? Okay. All right. So let's see if we can write summation notation for the series 1 plus 2 plus 3. For the first 6 terms. See if you can write it out. Summation notation. Don't find the sum yet, just write the summation notation. So fill in the lower bound, the upper bound, and the formula. Okay, Trey, help me out. Good. Good. Just an n. How many of you had 1 plus 1 times the quantity n minus 1? Is that the same thing? Distribute the 1, combine like terms. Doesn't it just simplify to plain old n? Okay. All right, now find the sum. Did you get it? Yeah? Okay. Do you see how we can go from an arithmetic series here to summation notation? From summation notation into your answer once you finally sum it all together? Do you see how that's working? Okay. Let's see. Do I have another one? Yeah, I'm going to let you do this one completely on your own. So write summation notation, then find the sum. All right, Brent, help me get started. On the top? Okay, good. Okay, so we're going from n equals 1 up to n equals 9. Good. Did you get a formula? Okay. I need parentheses around that whole thing, okay, because I'm doing the sum of that whole thing. All right? Yes?
So could we write it as like the distributed form?
Yes. And in fact, I want it also as the distributed form right now because I'm going to point something out to you. Did anybody distribute it? Did you do that? What'd you get? 5n minus 2. Now, it doesn't matter. These are the same thing. So I don't care how you write it. I like the simplified form just because it's a little bit simpler, but it doesn't matter. However, when things are being given to you, especially in your book, they're going to be given in the simplified form. Okay? Yes?
I don't understand how you did it before you simplified it. How do you get the 3 plus?
Okay, we did that before we started series. We did that back with the sequences, with the arithmetic sequences. Remember, a sub n was always equal to the first term plus the difference times the quantity n minus 1. Do you remember that from, it's been a while ago now because we had some time off here, but do you remember that? So that's all it is. Okay, the first term is 3. The difference was 5 times the quantity n minus 1. Okay? All right, any other questions on this? Okay, did you get the sum? Did you plug in and get the sum? 207? Okay, good. That's what I had as well. Any questions on how to get that sum once you have everything written down? Yeah? Okay, so the formula says to do n divided by 2, and what is n in this case? What's 9 divided by 2 times the first term, which you know, plus the 9th term, which you don't know, but you can figure out because all you have to do is plug in the upper bound in here. So when you plug the upper bound in there, you get what? 45 minus 2, 43? So it's 9 halves times 46, which means 9 times 23. Okay, so that's how we got 207. Okay? Any other questions on that? Now, yes?
So, from the notations in
That's a good question, and it really depends on what the lower bound is. Remember, n stands for basically the term number, which is essentially how many terms you're looking at, okay? In the cases that I've done so far, the answer to your question is yes, but that's because in every case so far, what has my lower bound been? 1, okay? So you kind of have to be careful. If my lower bound here had been a 3, then my upper bound wouldn't have been a 9, because I would have plugged in a 3, and then a 4, and then a 5, then a 6, then a 7, then an 8, then a 9. So then I would have only had 7 terms in that series instead of 9. Now, we can find a little formula to get that, okay? And I do want to go over that. How can you relate this upper bound and the lower bound to talk about the number of terms that you're going to have? What can you do with the upper and the lower bounds? Maybe divide them? Upper bound minus the lower bound plus 1. And that's what I would use. Number of terms will always equal the upper bound minus the lower bound plus 1. Okay, upper bound minus lower bound plus 1. Did you have a question? It's just a summation notation. It's one of your Greek letters. Does anybody know which one it is? What its name is? Maybe I'll throw that out there too. See if you, there you go. You'll find it. See if you can find it. See if you can figure out which one it is. Okay? Maybe. I want to let you look it up. All right. Yes, but it stands for summation notation. Okay? I mean, it stands for summation, I guess. That's what I'm going to let you look up. It's not that hard to find, but we'll see. It's not beta. And it's not pi. You'll find it. You'll have to find the Greek alphabet. So I'll leave that up to you to look up. All right, there you go. Okay. Now, here's a couple other things that I want to point out to you real fast. First of all, with all three of these examples that I've just done, all three of these have been what kind of series? Arithmetic, because its related sequence is an arithmetic sequence, right? If you take an arithmetic sequence and you write out its explicit formula, I want you to look at its equations. There was one formula, just 8n. Another one was 1n, or n, if you will. The third one that I looked at here was 5n minus 2. All three of those are special in what way? How are those three related? There's some kind of relationship. Okay, n's being multiplied by a number, that's a good start. If you just looked at all three of them, we had 8n, we had n, we had 5n minus 2. If these were equations, what is true about all of them? Ah, yeah, I heard it twice. They're all linear, right? Aren't they linear? Because that n is just a first degree. The thing that I want to point out to you is, if you're given something in summation notation, and it is linear, then what kind of series is it going to turn out to be? And if it's an arithmetic series, don't you have a shortcut for finding the sum? Don't we have a little formula for finding the sum of an arithmetic series? So we've just been doing over and over again, right? N over 2 times the first term plus the last term. Okay? So if this is your first one, it's the sum from n equals 1 up to n is equal to 4 of negative 2n plus 3. And you're asked to find this sum. Is it an arithmetic series? Yeah, because how do you know? Well, this thing right here is linear. If it's linear, it's arithmetic. Now, you could write out the terms and notice that it's going to be arithmetic, but you should already know that it's going to be. So all you need to do is do n over 2. Well, remember, to get n, we just had a little formula that we said we take the upper bound. So the number of terms is equal to the upper bound of 4 minus the lower bound plus 1. So this one, I didn't need to do that, but I just want to show you this is how it's done, right? So n is 4. They're going to be 4 terms. So we do 4 over 2 times. Now, we don't have any terms written out, so we have to figure out both the first and the last term. But they should be easy. To get the first term, all you have to do is plug in the lower bound. So when you plug in 1, you get 1. To get the last term, you just plug in the upper bound. Wouldn't that be the last term in that series? Whatever you get when you plug in the 4. So what do you get there? Negative 5. All right, so we end up with what? Negative 8. There's your answer. There's the sum. Okay? You don't have to list them all out. Okay, what about this next one? Is this next one an arithmetic series? Yeah, it is. Okay? So let's say this sum is going from n is equal to 7 up to n is equal to 12. Now here's one where I can't just do 12 divided by 2. It's not going to work. Right? Yes? I'm just making up the bounds. Okay? The computer program I was using didn't let me type them in the bounds, so I'm just putting them in for you. And they will be given, unless you're supposed to write this series yourself in summation notation, then you'll have to figure them. Okay, so let's see. How do I figure out what number goes over 2 for my formula? 12 minus 7 plus 1. Upper bound minus lower bound plus 1, which is 6. There would be 6 terms, the term you get when you plug in 7, 8, 9, 10, 11, and 12. Okay? Times. Okay, the first term. Well, what would the first term be? Well, what do you get when you plug in that 7? What do you get when you plug in the 12? So you're going to end up with 3 times 13, so 39. There's your sum. Okay, do you see how this is working? Okay. What? Yeah. Sometimes just reading it is a little tricky. Okay, what about this one? Is it arithmetic?
Yeah.
Yes, so can you use the formula? Okay, so I want you to find the sum from n equals 3 up to n equals, what? 42?
Yay.
Is that all right? So good? So far, so good? Okay. Plug in your upper bound into your formula. Okay? Is that what you got? Yeah. All right. You see how that's working? Okay. Where'd the 22 come from? Remember, this is the first term, and it's what you get when you plug in the lower bound. And then this one is the last term, and that's what you get when you plug in the upper bound. Now, whenever you're asked to write a series into this summation notation, there are really an infinite number of series that you could write, or summations that you could write, because your bounds could pretty much be anything. It's just easiest to start your bounds with 1. That's what I would recommend. Now, they won't always be given to you starting at 1, but if you're writing them, I would start them at 1. Okay, it's just going to be a lot easier that way. All right, I think I have one more to look at here. And this one I want to do n is equal, excuse me, n is equal to 2 up to 5 of n squared. Okay, is it linear? No, so can you use your formula? No. So if it's not linear, so you cannot use your formula, then guess what you need to do? You have to go term by term, plug it in, and find out your answers. And then add them, just like we did at the beginning. So you're going to start by plugging in 2, and then put in 3, plus what you get when you plug in 4, plus what you get when you plug in 5. And then just physically add them together. Now, it turns out that there really is a formula for this, for summing up n squareds and n cubes. However, we're not going to use enough of them right now for you to be required to know that. But what I do want you to know is that if that explicit formula in there is not linear, you cannot use that formula that we talked about before. Does that make sense? Yeah? Everybody got that? Okay, Then I think I have, let's see. See, I had bounds on these. On both cases, I want to go from 1 to 8. Are they going to be the same answer? That n over 2 times a sub 1 plus a sub n, okay? Because that can only be used for an arithmetic series, okay? Okay, raise your hand if these two answers are going to be the same. Raise your hand if you think these two answers are going to be different. All right, Nate, why do you think they're going to be different? Ella, why do you think they're going to be different? Okay, and I tend to agree. In the first one, what are you summing, Taylor? N plus 7. Seth, what are you summing in the second one?
N.
Just the n. And then after you sum the n, you're going to add a 7 onto the end. This one, here's what it would look like. You plug in 1 and you get 8. Plug in 2, you would get 9. Plug in 3, you get 10. And you're going to keep doing that all the way until you get to plugging in 8, which would be plus 15. Right? Now, is that arithmetic? Yeah, you should know that from this because it's linear, right? So we could just say, okay, well, there are 8 terms, so 8 divided by 2 times the first term, which was 8, plus the last term, which is 15, and you could get the sum without any problem. I hope, yes? Okay. Over here, here's what this sum is going to look like. First you plug in 1, and when you plug in 1, you just get out 1. Then you plug in 2, then you plug in the 3 and the 4, and you're going to keep doing that until you get up to the 8. And once you get all done, guess what? You add the 7 onto the very end. Okay? Parentheses are very important when you're talking about summation notation. Okay? You only are summing what is directly after that little symbol unless there's parentheses. Do you see the difference between these two? Everybody see the difference? I wanted to point that out and make sure that everybody saw that. Okay, then, so I just wrote this down as a note. It says you can only use the formula if that related sequence is arithmetic. If it's not an arithmetic sequence, once you take out the addition signs, then you need to do what? What do you need to do if it wasn't arithmetic? Natalie, what did we do? If it's not an arithmetic sequence or series, how are you going to figure it out? Yeah, otherwise you need to, and here's what I said, write out all the terms and add them. Okay? Let's see, a series will be arithmetic if the formula is linear. If it's not linear, and it's not arithmetic. Okay? All right. Let's see, we have to what, 51? Okay. Let me ask this. The assignment that was due for today, I'm assuming there were probably a few questions on that before you came in here. Have I pretty much covered what you might have had questions on? Yes? No? 34? Okay. Then I'm going to go ahead.